companies that are producing large language models. There's a lot of censorship and bias that goes on under the hood, all the way down the stack. So if you're building AI applications or agents, there's a very easy chance in the near future where your application is shut off or not able to be used because your agent's doing something that this centralized company doesn't want it to do. And we see that as censorship and of course bias being the way these agents are trained. And so we're going to be building AI in Korea for Korea, for the community here. We need to have systems that work with the community, are trained and modeled for use cases that are specific to the culture here. It doesn't make sense for us to have a technology that works for another side of the world and not where we're actually using. We have a lot of control and governance of AI applications that doesn't work in centralized AI. It's really up to the company that's serving you, the ChatGPT or the application. They're basically control and governing how you're able to use it, how you're able to monetize that data. There's a lot of privacy and IP issues. So as you're building out, building out your own AI architecture, you're kind of at the whim of a company, doing whatever they want with your data. It's a matter of time before this data is used, perhaps in a way that we don't acknowledge or want it to be used. And so we need to create systems that work for us, that are more decentralized and more user-owned. We also have economic constraints and operational issues. So if you want to build an AI application for a sophisticated use case that you want to build, you're kind of stuck using API calls that might not be economically viable for your application. There's also, again, a near future where these AI applications are charging astronomical fees in like a marketplace format. You can recall the Apple Store having 30% fees on any application being hosted there. Imagine a future where AI applications are facing similar economic constraints. Whereas if you're building a system that is running on your data and is hosted in a way that works for you and your developer community or your end users, you can build economics that help you monetize that data in a more robust way. Cool. We can actually skip this one. So what is inference and kind of what is under the hood of a ChatGPT, for example? It's not just AI. There's a lot of stuff going on in general, like computing and networking that we need to consider. And so you have machine learning, which has been going on for decades now. You have in current day large language models that have billions of dollars of research poured into them, taking neural networks and natural language and making it machine readable so that we can make predictions with like applications like OpenAI, for example. You type in a prompt, I want you to write me an essay. These large language models can think through how that recipe is made. On the compute side, we have different ways where you can run this large language model, or how you can run your application. There's various different levels of kind of resource allocation on the compute side of things. You have hosting, so how you're hosting your AI, or even your AI inference, or the database of this AI inference. And then we have UI, UX, so we have a lot of interfaces that we see on a daily basis, and how we use AI as a consumer or as a business. But there's also the future where we have a lack of an interface. We have a very near future where AI agents are the interface. We're just talking to AI agents all day, and the AI agents go and talk to our backend. So there's a lot of really interesting ways that we can kind of configure the architecture here. And last but not least, inference. And this is what we're focused on, where you take your data, your knowledge base and IP, and you pair that up with a large language model, and you vectorize it, or you kind of turn the natural language, the content, into a machine-readable format. We call that embedding. We'll go into that in the next slide. From there, that piece of inference, that whole process, we host in a decentralized way and enable for verification or validation of a global network of that instance, which is much lighter than having the entire world computer hosted for a specific context for one to use. Instead, you can have this giant library of knowledge that is your own data paired with a large language model, and anybody, any end user or developer can talk to that and pay for that that service, and you as the knowledge provider can make money kind of from that interaction. And so we see that as much more scalable, and not just us, but a lot of people in the AI ecosystem see inference as the kind of minimal viable resource that we can scale. We can skip this one too. I think I skipped this. Sorry guys. So the process of vectorizing your data and creating a sense of inference or embeddings this is very high level, but taking your knowledge base, taking any natural language, whether it's PDFs, doc files, like text, HTML, Markdown, and then you can also take any code or programming language. You turn that into, you basically vectorize it, chunk the data into a bunch of ones and zeros, so that if your AI, your LLM is crawling based on the color red and like the object of balloon, those two words are identified by a bracket of ones and zeros. And so the computer can actually go and predict the AI in a much more efficient manner. And so that is kind of what we host in this index of embeddings. And that's hosted in a product called a VectorDB. So we use open source technology called Qdrum in architecture, where you can host the embeddings in your architecture, and that itself is the inference that we're validating using blockchains. But yeah, in inference and vectorization, embedding, it's all kind of the same thing, but different pieces of the process. So this is more of a high-level approach on inference and how we look at it. You have kind of the machine learning kind of inference system that we're building at Gaia. It's a hosted node. So if you've deployed one of our Gaia nodes, awesome, thank you. Keep deploying nodes. But you're basically taking your ML model, so anything you can find on Hugging Face. There's 1.5 million open source large language models out there right now. We use a lot of Llama and Mistral in a lot of our nodes and our builds. But you can use any of these open source models. DeepSeek is like a big one that people are using right now. And with your inference, like how you're kind of taking the vectorized data and hosting it and running it against the machine learning, we're able to have this kind of sense of inference. And then what's really cool is on the, when you're putting data in and it's hitting the inference, you're able to, on the outside, get some sort of, you receive an output, which can be used for different applications. So if you have inference that is trained on like the Korean language, and that's hosted in a decentralized way that works for your application developers, you can essentially have your AI or AI agent talk to that inference, like put in some new data, like read me this paragraph in Korean, and it goes and contextualizes with the large language model and the inference, the verified inference, and then the output is a unique new output. So we see that as the whole process of decentralized inference, and we use Web3 to validate that whole process. All right, so this is Hugging Face. I'm not sure who's familiar with Hugging Face. Few? Who's a developer? Few? Okay, cool. Oh, sweet. Good people. So, if you're familiar with GitHub, even if you're not technical, GitHub is kind of a repository of open source technologies where you as a programmer can go and take code that's built in open source and use it for different applications. Hugging Face is basically that for large language models. And as I mentioned, there's currently 1.5 million different LLMs that are open for anyone to use. There's obviously different levels of which LLMs are most useful and for which use case. There's also a lot of them that are derivatives or forks of each other. But lo and behold, there's like 1.5 million of these, and there was about, I think, 500,000 in August of last year. So the scale of these models is growing vastly. And what we're seeing too is there's been years, and actually like a decade now, decades of research and development of these large language models. And even before that, they were machine learning and neural networks. We're seeing these models become cheaper to develop. DeepSeek was a really interesting, groundbreaking news that a team was able to spend $6 million on, supposedly, $6 million on an open source large language model compared to tens of billions of dollars spent on OpenAI's models, even Meta's Llama models. It's changing the game. So what we can see here is that there are going to be millions more smaller large language models that are trained on specific context. And so instead of asking an AI to translate a small paragraph in Korean and scan the entire internet to answer that question, why can't we just go to one node that specifically knows how to speak Korean and to translate at a much lighter weight? And so we're able to take the power of what's already open source and coordinate that in our architecture. And on top of that, so this is even not the entire ecosystem. If we had a page on the entire Web3 and AI ecosystem that works with open source and works with Gaia, I think I would need like 4 of these walls here. It's a very fast growing ecosystem. And I think what we want to demonstrate is that within the architecture of inference, you can have agents and AI that are doing functional tasks. You can have agents being play different roles on chain, or they can do things on the internet that we're not able to do previously. So we're seeing a lot more extensibility of what agents and this decentralized AI inference can do in applications. This is a question we get a lot. Why blockchain? I think earlier last year, the question of why blockchain was very much around, are we just using blockchain and Web3 as a term to perhaps raise more money or grow the decentralized AI ecosystem with buzzwords? I'll say that's not the case, maybe for some people, but blockchain is very useful for AI for a few reasons. One, for verifying inference. If we have this decentralized network of nodes that have LLM data or knowledge packaged inside of them, how do we know which ones to interact with? And so you need a blockchain to create a layer of trust where the community can stake if, for example, I'm using, say myself or an AI agent that represents me wants to translate a document into Korean. I want to go work with the nodes or the domains that are putting out the right outputs, that are actually the most verified. They have like a blue check mark on them. And so blockchains enable you to create that layer of trust with token economics and staking and different primitives like that. We also have kind of the compute and the data marketplace side of things, where you can use blockchains to coordinate resources, to create further encryption and verification with processes like ZKML, optimistic ML. There's a lot of things we've already built in the blockchain space that help us borrow that trust for helping AI exist on a decentralized network layer. We don't need to rebuild the wheel. We can really just pair up these two worlds, and it makes it 10x more valuable, to be honest. The other thing we have is with the advent of smart contracts and DAOs, we can actually have agents and AI architecture be governable. So I think a lot of the big issue we see in the kind of Web 2 or Silicon Valley kind of view of the world of AI is running rampant without any controls, without any safety built in. With blockchain, we can actually have these AIs have their own smart contract addresses, make them programmable, where you can have things like identity, reputation, programmed into the AI, where if the AIs are not doing something positive, you can actually give them negative reputation, or if they're doing a good job and they're being a good AI, you can give them positive reputation or identities. You start to see a world where AI agents can have the same kind of identification that we have as humans, which is quite interesting. And with that, what can they govern? Can they govern how money is spent on training up these large language models, or can they, with each other vote on how they want to spend money to perhaps buy more inference or pay for your inference or your data? And so those are very interesting things we can do with blockchains and smart contracts. We also have different integrations and economic models that the agents can have. So if you think about anything you can do on Web3, any intent or primitive that is transacting with a wallet, minting a token, whether it's fungible or non-fungible, voting on chain, permissioning tokens into a community based on something you hold in a wallet. There's all these interesting things you can do, even agent-fi, the whole anything you can do on DeFi as an individual, but imagine an agent can do those processes. All of that we see as extensibilities or applications for agents. I think, if you think about it, AI agents are for sure the largest population of unbanked we're going to see in the next 1 to 2 years. If you can imagine that right now, if you can imagine the next 1 to 2 years, we're going to have 6 to 8 billion AI agents on the internet, which is more humans on Earth. What does that look like for internet protocols? Again, you end up having the largest population of unbanked enter the internet. You have the largest population of entities without identification or IDs. And so we can start to create unique applications where these agents can perform financial transactions. And again, they're not going to go walk into a bank. They're going to want to set up a Web3 wallet. So there's some really cool applications that the agents themselves can have with Web3. I think I have one more. You can go to the next one. You can go to the next one too. Okay, so some of our architecture are key features. We have the Gaia nodes, which are, it's a protocol or framework that enables you to take a large language model, to take however you want to configure your compute and your own data, and basically host that in a way that works for your use case. So you can host the AI local on your machine. You can host it on GPU, CPU, cloud, and then we have an API suite where you can serve the API to agents, to applications, and you basically become your own version of OpenAI for a very specific use case. So whatever you train your node to be knowledgeable of. We have Gaia domains, which Gaia domains set the rules for which nodes can execute the routing or the coordination of inputs and outputs to an application. So if I'm asking, again, I'll use the Korean example, but if I'm asking a Korean domain to translate a document, I want to go find the nodes that can provide the most accurate output. So that whole coordination of routing is the relationship between nodes and domains. And then we have an agent architecture and a bunch of integrations with the likes of Coinbase Agent Starter Kit, Collaboline Agent Starter Kit, and Eliza OS. Basically, we see these frameworks proliferating on the internet. We want to be an available API endpoint for specific knowledge bases. So you can basically have your own AI on the back end of your agent versus giving your data straight to OpenAI or a centralized provider. And then we also have, last but not least, we have a bunch of Web3 integrations. So your agents or your architecture can interact with different Web3 functionalities. We are working closely with MetaMask community, Coinbase, Base, Eigenlayer, and ENS. Our domains are built on ENS. And so we have a lot of EVM compatible architecture where your AI can be compatible with various blockchains. Go to the next one. I think the slides got mixed up. Sorry, guys. This is just more of our architecture. And so basically, again, just kind of describing the nodes and domains and that relationship. Here's kind of how how you can pull your LLM into the API server. If you're technical, take a screenshot. Feel free to explore. I won't bore anybody with the architecture here, but very high level, as I mentioned, we have large language model. We have your RAG, which is kind of the inference that I mentioned that you built. And then we have the vector database I mentioned. And then we have a runtime where your agent can basically work on your own computer, GPU, CPU, cloud. It works very similar across these different interfaces. So if you have nodes that are on different devices or different setups, they can essentially work as a program, which is pretty cool. And then we have an application marketplace. So if you're building agents or any interesting apps or use cases that need AI on the back end, we have a whole suite where you can use open source decentralized AI for scaling your agents. That'd be the last slide. Yeah, so here's, if you're a developer, actually even if you're not technical, you can scan here. It's a quick start. If you're familiar with command line, you can launch your own Gaia node in under 10 minutes. If you need help, we have our DevRel team that can teach you how to do it. It's not super hard, even if you're non-technical. It's really cool to test out and see how you can be your own AI provider. I think that's about it. Yeah, that's it. Yeah. Thank you so much. I appreciate everyone's time.